Hi everyone, in this video I'm going to show you how to graph quadratics in standard form. So quadratics typically make a parabola shape, aka a U shape. So I have an example here in standard form. Standard form means it looks like this. It's y equals ax squared, and I'll write the standard form up here, just the general form. It's y equals ax squared plus bx plus c. And that's what our equation is in right now. So to start graphing this quadratic, you're going to find the axis of symmetry. So you're going to start with this formula. You're going to start with the formula x equals negative b over 2a. And you're going to plug in a and b. So we have negative, our b is the 12 over 2 times our a, which is the negative 2. So this leaves me with negative 12 over 2 times negative 2 is negative 4. So x equals 3. That is our axis of symmetry, x equals 3. This also means that it is the x in the vertex coordinates. So here on our next step, our vertex, I'm going to write a 3, comma, and your vertex is your highest or your lowest point on the parabola. So that just depends if it's a smiley face U-shape or a frowny face U-shape. So our vertex is 3 comma something. So to find our y, you're going to plug in the x to these x's in the original equation and solve it. So let's do that. Y equals negative 2 times 3 squared plus 12 times 3 minus 16. So I just replaced all those x's with 3. And now you can plug that into your calculator, just exactly how it looks, and I get 2. So I get y equals 2. So our vertex is 3 comma 2. So now we're going to find our x-intercepts. To do this, there's many ways to do this. I am going to factor. So I have, this is my original equation. The first thing I see is there's a greatest common factor of 2. It also starts with a negative, so I have to take a negative 2 out of this entire thing. So now I'm going to divide each of these terms by this negative 2 I'm taking out. So negative 2x squared divided by negative 2 is just x squared. Positive 12 divided by negative 2 is negative 6, bring down the x. And negative 16 divided by negative 2 is positive 8. And now I'm left with, in the parentheses, just a factoring problem. So I need 2 numbers that multiply to be 8, the last number, and add to be the middle number, negative 6. So I'm going to write out all my factors of 8. I have 1 and 8, and 2 and 4. If I make negative 2 and negative 4, negative 2 times negative 4 is negative 8, or is positive 8, so that checks out. And negative 2 minus 4 gets me negative 6. So I'm left with this equation, negative 2 times x minus 2 times x minus 4. And I'm going to set that equal to 0. And I apologize, I should have done that in the very beginning because we're solving an equation here. So let's move this y-intercept down since I need more space. So since it's equal to 0, and you have all these parentheses, use something called the zero product property. It sounds confusing, but it's super easy. All you do is set each of these terms equal to 0. So -2 is equal to 0. That does nothing, so don't worry about that. X minus 2 equals 0. X minus 4 equals 0. And solve any of the ones you can. So I undo subtraction with addition. So x equals 2. There's one x-intercept. Undo subtraction with addition. X equals 4. So those are my two x-intercepts. Sometimes you won't have x-intercepts. That just means it doesn't cross the x-axis, okay? Or sometimes you only have one. That means the vertex is probably on the x-axis. That's usually what that means. And now let's find our y-intercept. So for your y-intercept, all you're going to do is plug in 0 to the x's. So let's do that. Y equals -2 times 0 squared plus 12 times 0 minus 16. So y, this zeroes out, is -16. It's your y-intercept. Now, sometimes your teacher may want you to write your x-intercepts and your y-intercepts as points. So let's go ahead and do that in case your teacher wants that. So for your x-intercepts, to write them as points, this x equals 2 is 2, 0. Because technically for your x-intercepts, you set y equal to 0. And for your y-intercept, you set x equal to 0. So you also have 4, 0. And then down here we have 0, -16. So I'm going to go ahead and graph. Let me get a different color here. I'm going to graph the vertex, the x-intercepts, and the y-intercept. I'm going to go by 2s on my graph because I just didn't make it large enough. So my vertex is 3, 2, so I'm going to run 3. So I run 3, I'm at a halfway point here, and jump 2. There's my vertex. For my x-intercepts, my first one is run 2, jump 0. Run 4, so 2, 4, jump 0. And then plot your x-intercept. My x-intercept is 0, -16. So 2, 4, 6, 8, 10, 12, 14, 16. And you can go ahead and draw your quadratic. If you want to be a little more specific on where everything is, we know that these U-shapes, they mirror themselves. That's the point of the axis of symmetry. So see how these 2 points mirror each other? So that means you're going to have another point that mirrors this -16. So see, this is 2.5 away, so half 2. And I know that's not the best U shape. And that's how you graph your quadratic in standard form. The last thing I would check before you say this is your final answer is I would look and go, okay, I have this upside down parabola here. So see how it's concave down. Some people call it concave down. Some people call it negative. There's a lot of terms for it. That means your standard form started with a negative, which it did. So if you graphed this and you had something that looked like this, it was like a smiley face, then you know you graphed it incorrectly and you need to go back and check your points. So that's how you graph quadratics in standard form. I hope this helps. Feel free to subscribe to my channel if you want more math help. Thank you.